Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 28, another computational method for solving a linear system. Okay, so we just finished lesson 27, and in order to solve linear systems there, we graphed both of the equations and saw where they crossed or where the point of intersection was, where they intersected each other. Okay, now we have this system of inequalities, system of equations, linear equations, and we are going to, it says here, example one, use what you noticed about adding equivalent expressions to solve the following systems by elimination. So we're going to use elimination to do this. And what they mean is if you have two variables, xy, and their coefficients are opposites, like this, and you add them, well, negative 5 plus 5 is 0, and therefore 0y is simply 0, and they go away, and therefore they get eliminated. So what we're going to do to solve this system it's called elimination, is you take one equation, which is 6x minus 5y equals 21. And let me change colors while I do this, just at first to show you what's going on. So we have a 5y equals 21. And then we have 2x plus 5y, and that equals negative 5. Now, if I just take these two equations, line them up like they are, and add them, since they're opposites, when you add opposites, you get 0. So if I take 6x plus 2x, I get 8x. Okay, if I take a negative 5y and add 5y to it, I get 0y. And that equals 21 plus a negative 5, or 21 minus 5, which is 16. Well, this 0y just goes away, and we're left with 8x equals 16. And then I simply divide by 8 to find my x, and x equals 2. So we found x just by getting rid of the y. Now we're only half done right now. Now we know that our answer is the point 2 comma some y value. I now need to take that 2 and substitute it into one of these two equations, and it doesn't matter which one you use because that is the x value of the solution. So when you plug that x value into either one of these equations, you'll get the same y out, and I'll do that the first time only. So if I take the first equation, 6x, and say x is 2 minus 5y equals 21, then I get 12 minus 5y equals 21. And when I subtract 12 from both sides, I get a negative, don't forget this negative sign, I get negative 5y equals 21 minus 12 is 9, and I divide both sides by negative 5, and there's my y, negative 9/5. So now if I do that again in the other equation, and I say 2 times my x, which was 2, plus 5y equals negative 5, and 2 times 2 is 4. 4 plus 5y equals negative 5. And if I subtract 4 from both sides, then I get 5y equals negative 5 minus 4 is negative 9. And if I divide both sides by 5, I get y equals that same negative 9/5. And so that makes it true. So I did that to show you that the x value we find when we eliminate makes both equations true, or we find the same y that will make the equations true. Then it's only necessary to substitute the x into one of the equations and not both. Okay, so here's example 2. Solve the following systems by elimination. All right, so I have a negative 2x, I'll do this by color, plus 7y equals 5. And I have 4x minus 2y, and that equals 14. So if you're thinking from example 1, notice this is another example, not an exercise, so it's not like example 1 exactly. So notice here we had a negative 5 and a positive 5y, so therefore when we added we got 0y. Well, now looking at this problem here, we have a negative 2 and a positive 4. Those are not the same or opposite. And I have a 7 and a negative 2. Those aren't the same or opposite. So we need to do something here to adjust this. So I want to get opposites here. Well, I see right here that if I multiply negative 2 times 2, I get negative 4. So what we're going to do in this problem is we're going to multiply this problem, the top equation, by 2. And I'll leave this equation right here, and then when I do this distributive property, I'll just write it underneath here, and then we'll add these two. So if I multiply this now, I'll do the colors as well. 2 times a negative 2x is, and I'll write it down here, negative 4x. And then when I multiply 2 times 7y, I get 2 times 7, which is a positive 14y, equals, and then when I distribute the 2 over to this 5, then I'm going to get 2 times 5, which is 10. Equals 14 plus 10 is 24. Divide by 12, divide by 12. These cancel, y equals 2. Okay, so now I know that I need to find x, but I know that y is 2, so I need x. Take either equation, doesn't matter. I don't like starting with negatives, so it's just me. I'll just take 4x and take minus 2 times y, which is 2, and set it equal to 14. So I'm just substituting in my 2 for y right here, and there it is. That will give me 4x minus 4 equals 14. Add 4, add 4. 4x equals 14 plus 4 is 28. Divide by 4, divide by 4, and x equals 7. So that is the solution to that equation. That system is the 0.7, comma 2. Okay, example 3. Solve the following system by elimination. Well, now I'm looking at this one. I have a 7, I have a 3. They're not the same or opposite. I have a 5, I have a 3. They're not the same or opposite. So, in this situation, we just need to find multiples. We need to multiply both lines. So I'm going to rewrite the first equation, 7x minus 5y equals negative 2. And if I multiply it by 3, okay, so where am I getting that 3? I want to get rid of these 7. So pick a value, either get rid of the x's or the y's. I'll just get rid of the x's here. And 7 times 3 is 21. So if I multiply this top one by 3, and the bottom one by 7, well, 3 times 7 is 21, 7 times 3 is 21, and I'm going to get same values for x. So I'm going to multiply this by 7. I'm sorry, this by 3. So 3 times 7x is 21x. 3 times a negative 5 is negative 15y. And 3 times a negative 2 is a negative 6. So I've done that one. And now I'm going to, I'll do this over here. I'm going to take 7, and I'm going to make it a negative 7, because I want them to be opposite so I can add. If they're the same, I'd have to subtract, and we often make mistakes subtracting. So let's make it a negative 7 times 3x minus 3y equals 7. So if I distribute this, I get negative 21x. Distribute, negative times a negative is positive, be careful, 21y equals, and a negative times a positive is negative 49. Okay, so I'm going to write this underneath here and add negative 21x plus 21y equals negative 49. Okay, 21x minus 21x is 0. That goes away. Beautiful, that's what we wanted. Negative 15y minus 21y, be careful. I'm sorry, we're adding, put a plus sign out there. Negative 15y plus 21y is 6y equals negative 6 plus a negative 49 is a negative 55. Divide by 6, divide by 6, cancels, and y equals 55 over 6. Well, 9 times 6 is 54. the remainder of 1. So it's 9 and 1/6. So my y is 9 and 1/6. And I need to find my x. So if I take that 9 and 1/6 and plug it in here, pick either one, it doesn't matter. And I will use the 3x minus 3y equals 7. Take this y and put it right there. So I get 3x minus 3 times, and leave it 55/6 for now. Oh, I'm sorry, it's negative. I just saw that negative sign. Negative. Negative makes all the difference in the world. Okay, so now I'm going to plug in that negative 55/6 equals 7. Okay. All right, I don't like fractions, so multiply everything by 6. 6 times 3 is 18x. Minus 6 times 3 is 18. Actually, I don't want to do it that way. Disregard. Right here. Okay. See this 3? Think of that as 3 over 1. It's being multiplied. This 3 and this 6 will become 2. So I'm going to rewrite that. 3x minus, and a negative times a negative is positive, so it's now plus. And that is now going to be 55/2 instead of 55/6 equals 7. Okay, so my 3 over 1 times 55/6. 3 goes into 3 once, 3 goes into 6 twice, and that's how I got that. Negative times negative is positive. Okay, so now I'm going to multiply all of this by 2 because I don't like fractions. And I'm going to get 6x plus 55 equals 2 times 7, which is 14. Subtract 55, and I get 6x equals 55 minus 14 is 41, so it's a negative 41. And I divide by 6, and there is my x. Negative 41/6. 6 times 6 is 36, so that's a negative 6, the remainder of 5. So it's negative 6 and 5/6, comma, negative 9 and 1/6. Okay, here's an exercise that says that each of the following systems has a solution. Determine the solution to the system by eliminating one of the variables and verify the solution using the graph of this system here. So we're going to eliminate. So it's just as easy to just do this here. And because I see that the 7s are opposite, so if we add these two, the opposites cancel. So 6x plus 3x is 9x. Negative 7y plus 7y is 0. So they cancel, and negative 10 plus negative 8 is negative 18. Divide both sides by 9. X's cancel, and I get negative 2. So now I know that x is negative 2, and we need to find y. So I'm going to take either value, it doesn't matter, I'll take the second one and plug in my x. So 3x, which is negative 2, plus some 7y equals negative 8. Negative 6 plus 7y equals negative 8. Add 6, I get 7y equals negative 2. Divide both sides by 7, and I get y equals negative 2 over 7, 2 sevenths. Okay. So there we have it. Now what it's saying is graph both of these and verify their solutions. So remember that if I have 6x minus 7y equals negative 10, my m is negative a over b, and my y-intercept equals c over b. So negative a is negative 6 over b, which is negative 7. So my slope, or my a over b, is, my negative a over b is 6 over 7. Okay, and my y-intercept is c, negative 10, over b, which is negative 7, or 10 over 7, so negative divided by negative is positive. So this is an approximation, so I really don't like doing problems that are approximations on a graph, but anyhow, we will do this. Y-intercept is 10 sevenths, that's 1, and 3 sevenths, so I'm estimating here, it's approximately there. That's 1 3/7. I'm doing y-intercept. And then I do the slope, rise over run. Rise 6, run 7. So if I start here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 3, roughly there. So now I'm going to get my ruler and go up and retrieve it. Okay, and bring this over and try to be as accurate as possible here because we are looking for where the two lines will intersect. So it's really important we are right on with our calculation here. And there is my line. All right, I color code these, but I'll still label it. This is 6x minus 7y. Okay, I'll do the other one, this one in green. So I did this one in red. I'll do this one in green. So it's 3x plus 7y equals negative 8. M equals negative a over b, which equals negative 3 over 7. So there's my slope. My y-intercept equals c over b, which is c is negative 8 and b is 7. So that means go down 1 1/7, which is right about here, and then I rise, or I go down 3, right 7. So negative 3/7 means to go down 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7. So it's right about here. And my ruler's too close, so it won't let me write that. I got to start over. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I'm approximately there. Okay, bring my ruler over, swing it around, and draw my line. So it's got arrows, and this is the equation. 3x plus 7y equals negative 8. And we're looking for a solution, which is in this vicinity, and it should be negative 2 down 2/7. And sure enough, there's negative 2 right there, and we're down 2/7. Pretty close. So there we verified that it crossed at this point right here. Okay. Example 2 and 3 are the same. Try them, pause the video, and we'll see how you did. Okay, so I've done one for you. We're going to do it again. This one here, we have different values here. But if I look at this x and this x here, one's 1 and one is 5. If I multiply this top by negative 5, I will get a negative 5x. So we're going to multiply this one by negative 5. So I'm going to write negative 5. X minus 4y equals 7. Distribute negative 5x. Distribute positive 20y. Distribute equals negative 35. Now I'm going to write this over down below. 5x plus 9y equals 6. Add them. And we're going to get negative 5x plus 5x is nothing. It cancels. 20 plus 9 is 29y. Negative 35 plus 6 is negative 29. Divide by 29, and finally they gave us a number that isn't hard to work with. Y is negative 1. Okay, so I know these two lines are going to cross somewhere on this line here. Y equals negative 1. I'm sorry, y equals negative 1. So we're here somewhere along here. I just have to find the x value now. So I plug in negative 1 and do either one of these. It doesn't matter. How about the first one? X minus 4 times negative 1 equals 7. X minus a negative 4 or plus 4 equals 7. Subtract 4 and x equals 3. Beautiful. I have the point over 3, down 1. My two lines should cross right there. So now I'm going to graph those two lines. So focusing on that x minus 4y equals 7. And we know m equals negative a over b. Negative a is 1, so it's negative 1 over a negative 4. So my slope is 1 over 4. Negative divided by a negative is positive. My y-intercept equals C divided by B. C is 7. B is negative 4. So that is my y-intercept, negative 7/4. So negative 4/4, negative 7/4 is right here. It's negative 1 3/4. Okay, right about there. And my slope is up 1/4. So I'm going to be right about here. So far so good. I can tell that that black dot where my solution is going to be on my red line because it's in between the two dots I just plotted. Okay. And there's my line going through those 2 points and my solution point. And that is the equation x minus 4y equals 7. Okay, so now I'm going to do the other one. I'll use green. And it is the equation 5x plus 9y equals 6. M equals negative a over b, which is negative 5, over b, which is 9. So my slope is negative 5/9. My y-intercept, I'm careful not to use the letter b here for y-intercept because there's a b in the ABC naming my terms, and I don't want to confuse you. So the y-intercept is c divided by b, and c is 6, and b is 9, which reduces to 2/3. So my y-intercept is up 2/3, so it's about right there on the y-axis. My slope is negative 5/9. Go down 1, 2, 3, 4, 5, and right 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. And when I draw a line through those 2 points, and that black line dot, that black dot, which is my solution, should be on that line. And booyah, would you look at that? So we have x, 5x, plus 9y equals 6. So I solved it, and I confirmed using a graph that that's where those 2 points cross. Beautiful. All right, one last try. Here we go. Not the same, not the same. I'm going to have to do multiples. Okay. I'm going to multiply the top by 3 and the bottom by 2 to get rid of the x's. So 3 times 2x minus 3y equals negative 5 is distribute 6x, distribute minus 9y, distribute negative 15. Do the same with this one, and it is, now I'm going to multiply it by this coefficient because I want to get a common multiple of 6. So multiply 3x plus 5y plus 1 by 2. And distribute and get 6x. Distribute and get 10y. Distribute and get 2. Okay, so now I'm going to line that up. They're all connected, so never mind. I'm going to rewrite it. 6x plus 10y equals 2. I'm going to add these. Actually, what I should have done was multiply by a negative. And I didn't. So there's a way around that. I'm not going to add. I'm going to subtract. Be careful. I usually prefer to add. 6x minus 6x is 0. Negative 9 minus 10 is negative 19y. Negative 15 minus 2 is negative 17, and divide by negative 19. And they cancel, and y equals 17 over 19. So I have a point. 17 19ths. I need to find an x. So take one of these 2 equations, it doesn't matter which, and plug it in. 2x minus 3 times 17 over 19 equals negative 5. Okay, that will give me 2x minus 7 times 3 is 21, 3 times 1 plus 2 is 5, 51/19 equals negative 5. Multiply everything by 19 and get rid of that fraction. 19 times 2 is 38x minus 51 equals 19 times 5 is 90. 5. it's negative. Okay. Now I'm going to add 51. Do not know why they choose such odd numbers to explain the concept to you, but anyhow, 38x equals, and 95 minus 51 is 44, and it's going to be negative. Divide by 38, divide by 38. X equals, they're even, so I'm going to reduce. 22 over 19. So if I go over, and I'm going to plot this now, negative 22/19. Well, what is that? 3 more than 19, or 4, yeah, 3 more than 3/19. So it's negative 1 and 1/19. So it's really close to negative 1. But then it's up almost 1. So negative 1 and a little more, and then almost to negative. So my point is going to be right about somewhere in this region there. Okay, that's this point here. Now I'm going to graph these two. Ooh, I'm losing my voice. 2x minus 3y equals negative 5. Okay? The slope equals negative a over b, which is negative 2 over negative 3, which is 2/3. My y-intercept equals c over b, which equals negative 5 over negative 3, which is 5 over 3. So it's 1 and 2/3. So if I go up 1 and 2/3, I am right here. And if I go slope of 2/3, meaning go up 2 over 3, I'm right here. So if I draw that line, you will see that the 2 points I just came up with and that black dot are on the same line. Okay, here you go. And that is the equation 2x minus 3y equals negative 5. Okay, now I'm going to do the same with 3x plus 5y equals 1. And my slope is negative a over b. And if you write this every single time, it's a nice memorization process. Negative a is 3, so it's negative 3 over b, which is 5. There's my slope. My y-intercept equals c over b. And c is 1, and b is 5. So my y-intercept is 1/5. This is really close to 0. It's 1/5 of the way up to 1, so right about there. And my slope is negative 3/5, so that means go down 1. Go down 1, 2, 3, and over 1, 2, 3, 4, 5, which is right about here. And then I can already see this is going to work, because if I line up this like so, that black dot that we got for a solution is where those two lines are crossing, and this is the equation 3x plus 5y equals 1. So I've just confirmed that it does cross right there. Okay, so there you have it. That is the end of lesson 28. Review this lengthy summary. Go to your problem set.